Okay, hello everyone. My name is Ferdinand Radi, and I'm to a presentation about metallurgy and about topic. And the topic is modern alloy production. My presentation is from book source is Metallurgy for the Non-Metallurgist second edition by Arthur C. Riordan. And this content is 5.1 effect of alloying on solidification, and 5.2 is solidification structure, and 5.3 melting furnace, 5.4 molten metal processing, 5.5 primary production casting, 5.6 foundry casting, 5.7 non-ferrous casting alloys, and 5.8 is a powder metallurgy. And first 5.1 is a topic and the topic is effect of alloying on solidification. Alloying refers to the process of mixing two or more metal or a metal with a non-metal in order to enhance certain properties of the resulting materials. You can see the picture. This is you can see 5.1 picture is a table of the pragmatic is a temperate and liquidus metal and solid metal, and the salt is and the ground is a time, and you can see this is a picture in the piston in the block piston is a casting and the polytron. You can see in the left is a casting and in the right is a pattern. In the 5.2 is a solidification structure. Solidification structure is referred to the specific patterns and the arrangement of the crystal that form during the solidification of a molten metal or alloy. The structure are crucial determinants of the mechanical, thermal, and physical properties of the resulting material. Number one is a thermal supercooling, and two constitutional supercooling, and three solidification zones, four multi-freezing, five non-dendritic solidification for semi-solid processing. In the 5.3 melting furnace. A wide variety of furnace technologies are available for melting metals. In steel making, for example, pig iron is produced in a blast furnace from iron ore, limestone, and coke. In the figure 5.13, you can see the picture. This is a prepared limestone in the blast furnace and coke molten. This is why high-grade iron being materials. And the molten picture steel making furnace is an open heart, basic oxygen and electrode, and the weight scrap and leadly. And because it's a constant excessively high level of silicon, manganese, carbon, and other elements into moles. 5.3 melting furnace. You can see more the processing in the first electric arc furnace and induction furnace and vacuum induction melting and crucible furnace and remelting and other furnace. In the 5.4 in the topic is molten metal processing. Molten metal are processed and handled in various ways depending on the alloy and melting presses that are used. Melting is a basic way of combining elements for the purpose of alloying, and the overall chemical composition of the molten alloy must be carefully controlled and processed before casting can take place. And in the 5.5 primary production casting, primary production of metal normally involves either ingot casting or continuous casting of products such as strip, sheet, wire, or bar. Continuous casting over airtime benefit over static casting, but not all metal can be continuously cast. In this You can see the picture is about the schematic of vertical continuous casting process. And the first is molten metal, and the second is a water cooled mold, and the third solidification zone, and fourth water space, and the five solid metal, and this is turned to alternative in the static ingot casting and continuous casting process. And the 5.6 is a foundry casting. Foundries use various methods to cast parts with complex shapes and interior surface. Molds are made in a variety of ways, so that the molten metal poured into the mold cavity results in a part with the shape and dimension of the finished form. The choice of molding methods depends on the several factors such as part size and shape, quantity, tooling, and the molten metal being poured into the mold. You can see the picture in the figure 5.21 is a schematic of mold for direct chill casting of aluminum ingot. This is a more processing. This is on the staging table transfer section. This is a dummy solid casting, primary water inlet, secondary water, the mold, metal feed, floating distributor. In the 5.7, non-ferrous casting alloys. Non-ferrous casting alloys are metal alloys that do not contain iron as the primary elements. They are used in metallurgy for various casting processes to create components and parts with the specific properties. Unlike ferrous alloys, which are primarily based on iron, non-ferrous casting alloys offer distinct advantages such as corrosion resistance, lightweight properties, and improved electrical conductivity. You can see the table is cast alloys and there's some metric irons in this. In the 5.8, powder metallurgy. The development of powder metallurgy or PM processing metal powders can be produced using a wide variety of mechanical methods as well as by chemical and electrochemical methods. Atomization is the dominant method for producing metal and alloy powder from aluminum, brass, iron, low alloy steel, stainless steel, tool steel, superalloys, titanium alloys, and many other important industrial alloys. You can see the table 5.5 is the composition of zinc casting alloy. You can see this. And this is my presentation. If you that's is thank you.